It's basically an
reference.
index.
Yeah. But at a point in time. So if people upload more stuff or more references, that those aren't included.
Yeah, one of the things that we realize is missing, and we hadn't figured out how to, because we haven't spent the time on it, honestly, is how do you date timestamp something? Because not only is it copied across different registries, we georeplicate it across different regions, and we in region for availability zones. So how do you timestamp that? Is it timestamp when the manifest was created? Was it timestamp when it was first pushed to the first registry? How do you make sure you're keeping all the time servers in sync? So I think time is an interesting factor to that could give you interesting information.
I don't think that you can rely on user provider timestamps, right?
Agreed.
So you need something
That's
else.
part of the problem. Yeah.
You're basically going back to an OCI index at that point and getting rid of the whole reference concept. And so whoever is the author of that index can say, here's the target image and all the other artifacts that are associated with that image.
I guess if references are append only, then you can say honor the references only up to this given prefix.
To this given prefix, is that what you said?
To a given prefix, yeah. So like if you keep adding security scans and say security scans.
You only want the last N is what you're.
Or the first N, right?
First,
like,
yeah, whatever, yeah.
Security scans up to this.
Cool. It's so easy to start pulling threads and have fun with this one. So yes, but what you're kind of building on is there is something, what I'm hearing is there is something interesting here. How do we add that next layer to figure it out? Look, that's the exact kind of conversations we've been hoping to have. And instead of like, don't do it this way, do it that way. It's like, here, how can we do this? That's what I'm really trying to get to.
Mm-hmm. Makes sense. So, yeah, I mean, this is super valuable for us because like right now we have like 3 different APIs we have to talk to get metadata about an image. So this is useful.
Cool. All right, we're left with 15 minutes to the next session. I'm going to stop here, and everybody knows where to find each other. We'll figure out. Next step for me is we'll proceed with the TOB vote. That was the plan. There was a question that got a little confusing on what exactly the next steps were, but we'll ignore that. Amy? Oh, okay. Sure.
Yeah, Amy dropped. We are on our own.
I actually forgot who's next. That's what I was trying to pull up.
Yeah, I think it's me.
Okay. We'll see you in 15 minutes.
doesn't do that? No. I have a couple of people come like, "Oh, we're this guy." Like, no, you're not. Everybody's in the room.
Right.
Okay. Thank you. Thank you.
Thank you for checking.
Yeah, but they're like, "Man, I took me the bench." I'm like, "Yeah, but everybody's inside. You didn't break yet." Okay. Thank you.
Okay, can you guys see the main presentation?
Yes, we can see it.
The presentation is on the stream.
Cool.
Yep.
I apologize in advance for all the captions at the bottom. Somehow this captioning got turned on to my PowerPoint. I haven't figured out how to turn it off yet.
That's kind of useful. Did I see a Matt?
Someone say Matt?
A Matt? Sorry. Trying to figure out how my phone works. Out of hibernation. There he is.
Oh, hi there. Open containers. What's going
Is that what
on?
I'm showing up as?
Yeah, your name is Open Containers. So
That's not good.
you're not coming to KubeCon, right?
Said I wasn't loud enough. Is it better now?
Yeah, I can hear you now.
I think someone turned on a voice to text converter.
I think Rose
Yeah,
was
Rose
saying
was saying that it's, you know,
that was enabled in PowerPoint, and she doesn't know how to turn it off yet.
it's useful though.
Yeah, it is.
1 minute.
Okay, are you mostly ready to go? Mm,
The room's here mostly.
Okay,
Is that
okay, well, I'll just get started. They're not going to miss anything crucial. So hello, my name is Rose Judge. I'm an open source engineer at VMware and a OCI noob. And today I'm going to give a quick overview of SBOMs. So I'm going to go over what they are. You may already know about them, why we care about them, what cloud native artifacts look like in SBOMs, and some of the debates happening around that. And then I'll just give a brief overview of where we're headed with them in the future. So this is the only slide that has a graphic on it. I apologize, every other slide is very boring and white, so enjoy it while it lasts. But if you're like me and you've had a nickel for every time you've heard or used the word SBOM in the last 6 months, you would be approaching millionaire status. It's a very popular word right now, and I think there's a varying spectrum of understanding around it. So I'm sure you've all heard of the ingredients analogy, and SBOM being a list of ingredients that took part in the creation of your software. And the only thing I would add to this is that your SBOM is an ingredients list at a single point in time. So when the SBOM was assembled, it reflects the contents of your software at the point in time for which it was created, right? Which means that your software, as your software changes and evolves, so will your SBOM. Okay, so we know what an SBOM is, but what type of information is actually contained in an SBOM? And while the exact information is going to vary based on what's available, I want you to think of an SBOM as your blueprint to being able to reliably reproduce the software that it aims to represent. So your SBOM will hopefully contain metadata about the components inside it. This metadata might include things like the name of a package, its version, license, copyright, essentially any type of descriptor about the component. Your metadata will describe the components, but once those components are established, you might also want to include relationships between the components that ideally can represent all of the inputs into a build system in that SBOM. So not only direct dependencies, but transitive dependencies, compiler information, things like that. And lastly, I put here that an SBOM may point or link to another SBOM. So let's say that you have software A and it contains a component software B, but maybe software B is rather large and already has its own SBOM. Instead of rewriting the software B SBOM, maybe you save yourself the trouble and just link to that existing SBOM. So an SBOM may actually include other SBOMs. So we know what's in an SBOM, some of the information we can expect to find inside of it, but how are they actually generated? And there's a lot of tooling available to help with this, but of course the tooling will depend on the software that you're trying to represent. If you have a source code repository that you're trying to generate an SBOM for, you might use a file scanner. If you're trying to represent an operating system, you or presumably the tool that you're using will probably utilize some type of package manager. If you're trying to represent a container, maybe you use Turn, which can utilize both package and file scanning. And that is a shameless plug because I am a maintainer for Turn. But Most of the tools that are available today are going to be post-build analysis and inventory. So this means that you're going to create your SBOM for an artifact that has already been built. Especially when it comes to containers, this is mostly what we see. And post-build analysis does have its limitations. Build artifacts may have been thrown out by the time you have the final product. This is especially true if you're using Docker multi-stage builds where maybe entire build stages are no longer available to analyze, which can make it hard to represent, that comprehensive list of build inputs. And even if you do manage to generate an SBOM during build time, where all of that information would presumably be available, your SBOM is only as good as the metadata available. So there are lots of dependencies when it comes to generating a comprehensive SBOM. Okay, so what is all the rage about SBOMs? Why do we care about them? How can we make use of them? And SBOMs can come in handy in a variety of situations. I think the top of mind for everyone at the moment is the security use case, which is just that you can't know if a component of your software has a vulnerability, is compromised, if you don't know what the component is. So an SBOM, the goal is to help you identify what those components are so you can see when they might be affected by a vulnerability. Similarly, SBOMs can help you better understand your supply chain. So maybe you're using a component and you're unaware that it pulls in 30 other dependencies. Having an SBOM with all of the dependencies included in there maybe helps you realize that another component would be safer. So essentially an SBOM can help you understand the various risks associated with your supply chain and help you kind of visualize how they're connected, how the pieces are connected. SBOMs can also help us comply with open source license obligations. But in order to comply with any potential open source licenses, we first have to know what our software's build and run dependencies are and the licenses that govern them. So license information is part of the metadata component in the SBOM. And this is especially relevant for open source licenses, which may have certain obligations like, disclosing source code or attributions. Especially in the context of OCI and containers, we care about SBOMs because a Docker file or whatever build file you use is not generally declarative. I'm just going to use Dockerfile because I think it's one of the most ubiquitous forms of building a container, but there's no way to tell what actually gets installed in a container just by looking at its Docker file. There's a recursive challenge in tracking down the dependencies for your container, in addition to determining the corresponding licenses and sources when applicable for each of the components at the right point in time. SBOMs can also help you identify extra stuff in your software, maybe that you didn't know was being included or you don't want to ship, and can help you evaluate whether you really need it, whether you need to figure out how you're going to remove it before you ship. It can help with debugging. So this is especially true when it comes to software where you can't just upgrade away your problems, which is common in enterprise software. So, if you're running a certain version of a data center or virtual data center, you're probably not just going to say, okay, let's just upgrade it. That there's a lot of work that goes into it. But if you're supporting this software like this, and you want to reproduce a bug, maybe in that dev environment, like you have upgraded certain packages and you can't reproduce the bug. So that SBOM is going to be your clue or a hint, like this is the component, or this is the level that the components were at when we saw the bug. Let me match with that and then debug, try to reproduce the issue from there. SBOMs are also just a way to establish trust as a software provider, volunteering this information, which can be verified, of course, kind of says to your consumers, you know, I have nothing to hide, but here's what I'm giving you. And you might even have other applications or use cases for SBOMs. But as my colleague Nisha says, the bottom line with SBOMs is that you don't need them until you need them. And then you really need them. So yeah, SBOMs, we care about SBOMs. I care about SBOMs, but I think you should too. And oh yeah, there's this whole executive order thing on improving the nation's cybersecurity that came out in May. That also says if you're selling software to the government, you must have a software bill of materials. So it's not just a should thing, it's a must thing. And the software bill of materials defined by the executive order is a formal record containing the details and supply chain relationships of various components used in the building of software. And the link is here if you haven't heard about that, which I'd be surprised, but if you want to see more about that. Okay, so the NTIA is the National Telecommunications and Information Administration, which is one of the government agencies responsible for establishing acceptable SBOM standards in relationship to this executive order. And since the executive order, they have came out and said that there's these 7 minimum elements which must be included in all quote valid SBOMs. And that is supplier name, component name, version of the component, other unique identifiers, which is very broadly defined right now, dependency relationship, author of the SBOM data, and the timestamp. And I think, you know, these are subject to change as this executive order kind of evolves and takes shape, but this is what these minimum elements are right now. And then there's 3 SBOM specifications that are currently able to represent these minimum elements in accordance with the NTIA's expectations. There's SPDX, which is a Linux Foundation project, Cyclone DX from OWASP, and then Software ID Tags, which is part of the National Institute of Standards and Technology. I think SPDX and Cyclone DX are the most popular right now for what we see, and just kind of use of one standard or the other just kind of depends on your use case. So as SBOMs become more sophisticated and we try to represent many different types of software artifacts and relationships in these SBOMs, and as you have multiple different vendors producing SBOMs that may be describing the same artifact, we start to think about this idea of a universal identifier as a way to refer to or represent artifacts in SBOMs. Of course, there will be other ways we can describe this artifact in an SBOM using that metadata we collected about it. But a universal identifier, or URI or IRI, as you may hear them referred to, can help us do things like compare 2 artifacts and SBOMs produced by different vendors and deduce that they're in fact the same thing. They can also help us do things like you know, joining CVEs for components and linking that to some type of CVE database, or recognizing that this component is represented in the CVE database. And then there's the question of how to actually locate the artifact, and should location for cloud native artifacts be part of this unique identifier. I think cloud native is a bit special in this regard, given its content addressable nature and the way that artifacts may persist through different locations. So how do we locate these artifacts? And then there's also this idea of like, do we need to? The idea of zero trust, that's also been popular parallel to SBOMs, kind of plays nicely into this idea of separating identity and location. And I stole this definition of zero trust from Dan Lawrence's OSS talk this week, but I think this was the clearest definition for it that I've seen, which is, you know, you want to trust what the artifact is, not where the artifact is. And so should that identity contain location when it comes to cloud native artifacts? But this all boils down to making it easy and convenient to reference artifacts in SBOMs when we typically think of SBOMs representing not cloud native artifacts. Okay. So clearly, I think SBOMs are an important aspect to securing the software supply chain, but they're not the only thing, and they're really just the first step. So with any of these SBOM specs, it's technically very easy and possible to create a quote valid SBOM that doesn't actually contain any useful information. Unless so if you, for SPDX and CycloneDX, they have like SBOM validators to make sure that your SBOM is quote a valid SBOM based on the spec, but unless the validation tool knows something about the artifact that the SBOM is describing, there's no way for the spec to say, you know, this SBOM is incomplete or incorrect. So it's up to the supplier to create an SBOM that can actually be used to provide context and assess risk. And this is what that NTIA's, or what the NTIA's minimum elements for an SBOM is trying to establish, which is some baseline to make sure that SBOMs can be useful. If we take a step past actually creating the SBOM, we find ourselves in a place where we can actually start to use it. So maybe this looks like cross-referencing a CVE database to find if there's any vulnerable components in your software. This might look like actually distributing the SBOM with your artifact, which is, I think, something that we think about generating the SBOM and then it's there, but how do we actually distribute this in a meaningful way? Because of course, if the SBOM exists, but no one can access it, then does it actually exist? No, not really. And then of course, further security measures like signing your SBOM or associating it with some type of secure hash so that you can ensure it hasn't been tampered with in the travel process or in the distribution process to your consumers. And while I don't think that the processes around SBOMs and license compliance and security will ever be 100% autonomous, I do think that the more we can automate the generation and consumption and the rules around SBOMs, the more effective they're going to be because people are more likely to use things that are intuitive and make their life easier. Okay, so as we look ahead in SBOM land, what do we see? Nisha and I are involved in the SPDX community, but I don't know if any of you are involved in CycloneDX or SWID. But if you are, you know that these specs are evolving, and as they do, we want to continue to develop comprehensive SBOMs that work for all types of software. And cloud native being a bit of an apple and a bucket of oranges, we want to continue to advocate for cloud native artifacts and their relationships to one another in these SBOMs to make sure that the spec can still be useful. So that's kind of an ongoing and future looking effort. I mentioned this on the last slide as well. And I want to give credit to Nisha, who's been working on this for a long time and continues to work on this, but hopefully the future will hold a more robust solution for how we can meaningfully distribute SBOMs with their artifacts and then manage these things in registries. So yes, we know registries can be used to store metadata, but how should we reference and link these things to the artifact, and then how do we update them when necessary, and how do we clean them up when they no longer exist, and how do we make this possible for users and registries. I also put a link to a blog post that Nisha wrote about this that does a really good job of summarizing the to-dos around this and kind of where we're at. So that's there if you're interested. There's also talk now and in the future about this concept of micro SBOMs and how that might enable us to link SBOMs together. So the concept of a micro SBOM is this idea that there are many different software components. Each will have its own life cycle and origins, and thus each can be represented with their own component level SBOM. And then a total product SBOM would essentially be a collection of these smaller SBOMs, with the reasoning being that there are valid use cases to distribute both the higher level SBOM as a whole, or in parts, depending on the situation. So SPDX can technically link to other SBOMs right now using the external ref property. It's missing, I think, for this to be effective, we need to add tooling that could potentially flatten SBOMs. So if you had a high level SBOM with just references, having some sort of tool that could pull in these references and flatten it into one big document. There's also security considerations. If you have certain components that you only want to share with certain parties, how do you do that? And then also tools to help us update these high-level SBOMs that have references to micro SBOMs. So as components change, as micro SBOMs need to be updated or deleted or replaced, how do we do that? So tooling for all of that is hopefully coming in the future, or at least will exist in the future. And then last year I have the vulnerability exploitability exchange, and there's a typo there, it should say exchange, not exchange. I added that late. Nisha just sent this to me today. It came out 2 days ago. And it's a concept from the NTIA, which basically establishes guidelines around how we can communicate the impact of a specific vulnerability. So for example, sometimes you have a product that contains a component with a CVE in its supply chain, but for whatever reason, the final product is not actually exploitable by the CVE. VEX was created as a way to communicate, hey, this component is not actually affected, so that readers of the SBOM can reason about it, and understand the correct implications of risk. Or maybe you want to communicate that a component is affected, but a fix has been applied to a particular version, so it's not vulnerable anymore. The point is that you could communicate it with VEX. So this is only a few days old, but it'll definitely be interesting to see how the SBOM standards adopt to something like this. And that's all I had for today. I left, tried to leave 5 to 10 minutes for discussion or questions, but yeah, that's what I got.
I saw Tinon had.
Maybe that was a clap, not a hand raise.
Yeah, a virtual clap as well. It's a really interesting space. So thanks, Rose, for putting it all together. One of the things I've been curious, you mentioned like the validations of it, and I've heard discussions on validating that the SBOM format is valid. If somebody didn't malform the JSON YAML, whatever the physical format is. But one of the examples that I've been trying to use was the whole soup for you thing. If there two parts. One, is there a lot of focus on what went into building the content? Because the soup analogy is interesting in that it's really difficult to look at soup after it's cooked and figure out what went into it. Right? You're talking DNA analysis as opposed to just listing the ingredients you poured in the pot. And when you're building software, especially on compiled software, what went into it versus software that just has package references even in the runtime deployed. So one question is, have you put more thought into the importance of having the SBOM built on what went into it, including the compiler flags, versus analysis after it's built, and if validation can be done, where does the validation happen that says, my policy is I don't allow pepper and I must have salt, and whatever the vulnerable package that I don't want deployed, I just like playing with the salt and pepper soup scenario. Is that an SBOM? Like, is that an SPDX or Cyclone DX validation? Or is the thought that those SBOMs produce content and its other tooling that should create policy and validation based on the content that is in the SBOM?
I think policy is going to be on a per user basis, right? Each organization is going to have a different level of risk that they're comfortable with, and that's going to be reflected in their policy. However, I mean, we've talked about, Nish and I have talked about like some type of tooling that is configurable for the different use cases. So company A says, I don't want salt, then, they would run the SBOM through this validator that says, okay, well, bad news, we found salt. So, but that list of what wasn't allowed would be set by the user doing the validation. So that is something that we've talked about. I'm sorry if I missed another part of your question, but
no, on that one though, because before you go to the other part, is that the SPDX tool that should do it, or is the SPDX community saying they're not going to worry about validation, they're going to worry about getting that list of ingredients into it, and it's another tool's responsibility to decide how to configure that policy? Like, I'm just trying to figure out, is it other tools, or is the assumption that it's those tools that will incorporate that policy validation in addition to getting the content in it?
I think it could be not necessarily the SPDX validation tool, but it could be a tool in the SPDX org, especially if it was focused on SPDX documents. But right now, the SPDX validation is only, is this, like you said, is this the correct JSON format? And I think SPDX is also focused more on the content of the SBOM so that folks can make those decisions about policy or how they want to interpret the SBOM, and that takes up most of their time versus like building a tool that could do that validation. But ownership commented something.
Makes sense. And just the other question was, what do you think about the value of SBOM understanding the ingredients that went into something instead of analyzing after the soup was made?
Can you say that again? I was reading Nish's comments.
Where do you think the value of the SBOMs are for reading the content, reading the ingredients of what went into it, kind of the build system side, versus analyzing after the image was built, trying to decompose what went into it? Because, like, for instance, you can't tell what the compiler flag is if you're looking at an image that was built, as opposed to evaluating when the image was built, what were the ingredients that went into it?
Yeah. Well, I think,
I can jump in here if you want, Rose.
Sure.
Yeah, so I put in the chat the containers with SBOMs a talk that I gave yesterday. And it allows you to generate SBOMs at container build time. You could totally insert a validator either during that time or after the fact on the SBOMs to verify if there's soup in there or not. But that specific auditing tool doesn't exist right now.
Okay. I guess, do you think it's important to make sure we're building tools that analyze it, what goes into it, as opposed to after the fact? Where do you see the importance of that?
So, I mean, there are, So it's an empty space as far as like auditing and editing and manipulating the SBOMs. This is what Alan Friedman calls the SBOM data plane. And it's a nice opportunity there to create tools for that. But what you were saying was, is there any way to evaluate the SBOMs before all the ingredients go in and get mixed up and stuff like that? And my answer to that is this GitHub thing that I posted, which is as you're building the container image, you generate the SBOMs, you move the SBOMs along with the final image, and you can do auditing on the final SBOMs, or you can do auditing during container builds.
Yeah, I'm like, a security, I didn't see anybody else's hand, so I'm just trying to continue the conversation. Security scanners look at images after they're built.
Yeah.
So there's only so much you can do because it's already been compiled. Kind of like, that's kind of the soup analogy. If the SBOM captures what went into it because it knows exactly what went into it and is supposed to inferring, there seems to be a lot more value that security scanners can't get access to, because they don't run, well, they do, but there's different types of scanners.
Yeah, no, so if you're thinking about the Go use case where all you get at the end is a binary blob, yeah, you could probably decipher something out of it, but not as accurate as you would like. But it would be nice if there was like an SBOM available from the producer of that binary blob that an auditor or a scanner can use. If that makes any sense.
Yeah, that's kind of what I was leading at. Oh, that's right, there's no break here. Yeah. Okay, so since Amy's gone, we'll...
No, I'm still here. It was just like that. You guys became awfully mumbly, and I was like, what happened in here? We do, however, have a chance to be able to move on, and then we've got an opportunity to be able to do like kind of closing and next steps at the end. So,
do you want to read the closing and next steps, or?
Oh, no. Like, you are absolutely next. You are our next speaker. Rock and roll.
So yeah, I wanted to talk about alternative file system representations and potentially moving past what we have today. So what do we have today? We have layers, and layers made a lot of sense at the time. They were adopted from Docker, and Docker had an amazing story around builds where you could, take a bunch of base layers that someone else had built and just change your binary over and over again and take advantage of these layers. But over time, they've started to show their age, and they have issues. So within a given image, because each layer is stored independently and compressed independently, you end up inadvertently getting duplication of data within images if you say change a few bytes of a file. Within a given system that's running multiple images, if those layers are stored discretely and there's no kind of offline deduplication process, you can end up with a system that's duplicating the same files or dozens of times across layers. And that's actually like a pretty common thing because of things like Node.js, where everyone seems to have every package, but they can't be cached into a single layer due to the nature of the build tools. And then kind of worst of all, where we see this problem is registries, where over time there's a lot of files and a lot of stuff that can be shared between different layers inside of a registry, but there's no way that a registry, or there's no trivial way a registry can go ahead and deduplicate that data across multiple layers. There's also a variety of failure modes that result in unnecessary information transfer, and the biggest one of these is non-access data. The last thing is that layers don't necessarily lend themselves to verifiability the storage on disk. Although you can reassemble a layer back to what it was before, you have to store it in a way where it has not yet been applied, and that can be messy. So yeah, how does this actually happen? If you have two files in different layers, there's no compression across them. The other case where you end up with unnecessary information transfer is where you overwrite a file, and the runtime node will still have to download the old layer, even though that there's a newer piece of data that's replacing the old piece of data.
Or whiteout. Don't whiteouts get downloaded and then removed?
Yeah, but you still have to download the previous layer.
Can you repeat the question?
Oh, sorry, my fault. I was just saying it's not just the renaming, it's not the new version of the same file name. Even whiteouts get like, you download the file just to have another layer say, yeah, by the way, I deleted it.
Yeah, I mean, to give some statistics, I think like whiteouts are less than 1% of the reason behind our duplication, whereas people basically like touching a file and updating the timestamp, that's it.
The whiteout, I think, is also zero size. You're not downloading the entire content of the file you're deleting.
But again, you did download the layer previous to that.
Yes.
So
you're downloading a file that you actually never wanted, or in the aggregation.
Right.
But you're saying a lot of them are just touches to change the timestamp?
Well, so like if someone runs a build, a lot of build tools will touch files for. I don't understand Node.js, man. Like it does some stuff. But yeah, like you know, going back to Node right here, where we have a lot of Node on our systems, you end up having your app plus Node modules, and even though like you know, majority of those Node modules are shared between different applications since they're built on the same frameworks, we can't deduplicate that data without having some kind of offline scan process or some kind of system that will do this in a out of band manner. In the layer specification, there's no mechanism to say, hey, all of these files between Node modules are shared. And the eStarGZ people have published this statistic. Our data shows differently, but according to them, only 6.4% of the data is actually accessed when people are running images, and all of that data that you're downloading those layers is basically useless because you're not accessing it, you're not using it.
I guess that's high too, because it's probably measured at a file size granularity.
Yeah, so machine learning people use a lot of data in their images, but like application people or applications don't tend to touch a lot more than like their service, right? So there's like interesting bimodal distribution. So like kind of going back to Steve's presentation earlier, there's not one good solution for everyone. And in some cases, you do need to optimize for a majority of the data being accessed.
ML images versus there's all kinds of different.
Yeah, I'd say that there's two classes of ML. There's people who have models in their images, and those models can get into the hundreds of megabytes or gigabytes. And then you have people who are training, and the people who are training are like, I just installed TensorFlow and PyTorch and you know the other 800 different machine learning frameworks. So if they need them one day, they'll have them, and those are much lower. Because the layer specification is built on top of tar, and tar kind of captures everything about the file because it's meant to be like a backup tool, basically, we end up getting some unnecessary metadata inside of the image. Now, like image builders have gotten better about this and strip out things like unnecessary X adders. But still, there's nothing in the specification itself that prevents this unnecessary metadata from entering the image or entering the layer itself. And this can, again, end up with excess data in registry in unnecessary layer downloads where that image, that given blob could be cached. And then the verifiability storage at rest use case is really around systems where you might have a reboot, or you might have a system where you're accessing a remote file system. So like if you say have a layer on NFS, or a layer on like S3, you can't, once it's exploded, and you're using it as a file system, you can't easily go back and actually verify from all of those files, or at the time that you're accessing those files, if they're not tampered with. The only way to go about doing this is by taking all of those files, reassembling the full layer, and then figuring out whether or not that one file has been tampered with. And this doesn't really work with the integrity measurement architecture that's available inside of the kernel, nor does it really work with any kind of like off-the-shelf integrity measurement architecture. So this is actually what I wanted to talk about. Here are all the those are all the problems, but like, what could we do alternatively to layers that would give us a better story? And I kind of put together a document that's outlines a strawman proposal of how we might attack this, and the idea is to adopt a file system manifest. The file system manifest is a canonical form that describes the file system and allows the user to reassemble a container file system or an image without having to have all of the data available at the same time. So it disentangles the metadata about the file system representation from the actual data itself. And this works with existing registries because each file is stored as a blob, and this file system manifest is its own blob that the OCI, that the actual manifest points to. So if anyone read, can I actually like see if anyone read the doc that I posted? Hands would be cool. 1, 2, no, okay. All right, John. All right, cool. So yeah, I mean, in the doc, the idea is, or it talks about the fact that canonicalization is very important for this because you need to have the same, or for caching, you need to be able to go back to the same representation, and a lot of the it's Anisha, there's a doc linked in the agenda from this this slot. Yeah, so canonicalization is important because you have to be able to get back to that original manifest file for verifiability. And a lot of the previous attempts at this have been around, like, you know, JSON. And JSON is great. I love JSON, but it's not great for verifiability, and it's not really great for like being able to reproduce the same data. Since I've been working on this, there has been like a published specification that's been accepted of how to canonicalize JSON, but that literally was published like less than a year and a half ago. And there's a bunch of people who have alternative canonicalization approaches. They're just not available everywhere. So CBOR is what I proposed using. CBOR is a binary format that's standardized by IETF. It's very similar to JSON, but it has first-class data types for a lot of things. So things like date times for timestamps for files are a first-class thing, and they follow like RFC 3399, I believe. They have sets, so for unordered things, those are first-class citizens. And there's a canonicalization capability built into the specification itself. And there's a schema checking mechanism built into the specification itself called CDDL. And it's just kind of a starting point. I'm not necessarily saying that CBOR is the best format here, but it kind of is a format that fulfills these requirements. Because every file is an independent blob that you have to fetch independently, that can result in some interesting performance problems. So HTTP is like not great because of the fact that you have to like usually make a new connection. you end up having to do request response. Pipelining isn't really a thing, and for a lot of registries, they're still using HTTP 1.1, so you have to end up making lots of different connections if you want to get any kind of parallel fetch. Now, the good news here is that like because so little data in these layers is accessed, you can end up lazy loading quite a bit as opposed to having to fetch every file. And one interesting thing is moving away from large layers to lots of tiny files actually shows better performance in some cases because it allows you to load balance across your entire storage layer as opposed to saying, contending on one TCP connection or trying to do clever things like chunk up the download of one layer across multiple connections using range requests. Now, saying that, like, distribution spec can be improved, and unfortunately, like the peak of file transfer protocol still seems to be like FTP and SFTP. There hasn't been a ton of standards released for public data distribution from machine to machine use cases in the data center, but there's a lot of existing work here for other systems like big data systems like Hadoop, and that we can take advantage of. And then there's an idea in StarGZ. There's an idea in StarGZ where the registry or there can be metadata about which files to download in which order. And the registry can have that information and push data down to the client in the order that it thinks that data will be downloaded in. The proposal does not solve block level dedupe. That's an open problem. So eStarGZ, I think, is actually a very good starting place here. It has a couple places where it lacks. It doesn't fulfill the minimal metadata case because it has to support everything that's in the current layer specification. So it doesn't say, X adders are limited to some subset. In addition to that, it doesn't actually require the metadata to be able to recreate the full file because many fields are marked as optional, and you can end up with a piece of data that has no information about the UID nor the username for a file, so you're unable to actually create it, and you have to fill that in, and different runtimes can handle that differently. And then the last issue is the TOC and the data are still combined in the same storage. So you can't end up having things like faster metadata storage versus blob storage for your actual files. So yeah, I want to get kind of a read in the room of how people feel about this. Do people think that we need to get past layers? If people think we need to get past layers, does this file system manifest approach seem interesting? And if it does, what are the next steps? Brandon?
Yeah, I don't see anybody else with a hand. A lot of the stuff that's going on with the layers today follows very tightly with how Linux is doing it on the file system for the overlay 2 file system under us. And so how much of this is just handling the registry and the transport, or does it also apply at that runtime client side?
So OCI actually addresses the on-disk storage and runtime in 2 ways. So one, it actually works really well with the VFS style backend, where all of the files are stored in their content addressable form, or in a directory with their content addressable digest. And then that content addressable digest is ref linked in to the runtime directory. Now, most images have thousands of files, and this can take hundreds of milliseconds to do. Metadata operations aren't free in Linux. So if you want to take advantage of something like OverlayFS, the approach that we've taken is using OverlayFS with views and having a fuse file system underneath OverlayFS. And that fuse file system is the one that's actually populating the data on disk. And Fuse has a feature where it can pass through the file descriptor, once it's stored on disk. So you don't have to pay the performance penalty every time that you're accessing the data. It's only on that first metadata operation. And then there's enhancements that we've looked into doing with OverlayFS that like once the entire layer is downloaded, you could, or not layer, the entire file system is downloaded, you can swap out that piece of the stack with a different directory rather than a fuse file system. The fuse is just there to enable lazy loading.
Thanks.
How far have you gotten with this? Because we've experimented with a couple of different approaches, the SMB mounts, and then how do we mount all the files? And there's been lots of trade-offs we've been playing with. I'm just curious how far you've gotten with this to see what the real data starts looking like.
So I'll be honest, this hasn't like gone into production. And the biggest reason is because we use so much off-the-shelf stuff in the OCI ecosystem, and like Docker on people's laptops is still the way that so much development gets done. It's so hard to evolve production without having the ability to say, all of dev, go get this custom version of Docker or this custom image builder and starting there. We've played around with it in development. We've taken quite a few of our images and processed them through this mechanism just to see how it would work. And we've seen fairly good results. The biggest problems that we've seen are tackling the cross-file compression problem. So you have to do something like create a dictionary. So we using a zstd dictionary, and then sharing that across many different files to get really decent compression ratios. But that's complicated. So that was not in the document. And then the other thing is there's a lot of performance complications when you're downloading this many files at once.
Yeah, that's why I'm trying to poke at is like that's I'm sure how far you've got with it, because it's a great, it's super interesting idea. It's the devil's in the details of, when you start going down the path, this all part is great, and then there's this side effect. So I'm just curious where you pivoted. Like, are you side building them? So like one of the things that we've been doing is you still have a container image in the registry, but when it's pushed, we create this expanded layer, expanded area of that, so you can actually pull that. You could do the same thing as not just expand it, but separate it into thousands of files. And I'm just curious how far you've gotten with that to see.
So we've played with the idea of like after the image is uploaded as a what we call development format, turning it into a runtime format, because you have different requirements for both. And it's possible, but you can't alter the manifest without changing the digest. And since our entire ecosystem relies on digests, it's not something that's easy to do, which is why your like whole references thing was very interesting. So we'd like to see that happen. But going back to the performance things, a lot of the data that we have is not necessarily data that other people will see because we've spent a lot of time optimizing moving around lots of files. And we have an in-house file system. And that's not something that people will necessarily be able to take advantage of. So I'm kind of curious with how other people are storing their images. Are they relying on like nearline storage, or do they have like a NAS with fast storage? Like, how are people actually doing this?
That was some of the projects that I was working on when I was still, even at Red Hat. It was just like how to have a backing graph effectively of whether it's Ceph or otherwise of read-only images, so that the nodes that are actually running them would never actually do any fetches. They would just be available already on disk, so that they're all in proximity and fast. But this is what you're describing is what I always wanted to get towards.
Yeah, the idea of like using Ceph or like NFS is kind of well in alignment, or even like HDFS.
Yeah, because the other thing that we thought about doing was effectively having almost like OS tree, where you have a bunch of objects and you even have like a store of like checksum down to the file object layer, and you could have, like you said, some kind of fuse implementation fuse overlay, like Giuseppe was working on, that could fetch them as needed. But yeah, it's still down the same path. And like I said in the Slack, this is why I was like investigating things like even the old BSD M tree, where you could have like a machine parsable manifest that could have a variety of checksums, like several different types of checksums and attributes about them. And so you could represent them almost on the fly or know what you're looking for. And as soon as like there's the first read, you could fetch them or otherwise, but it's very much down the same path.
Yeah, I guess like backing up a little bit, do other people see this as a more valuable approach than layers, or do they see this as an addition to layers as like a runtime format, or is this not interesting to people at all?
I'd say somewhere between, because the runtime is good for the runtime to know, so that you could have like various optimizations on fetch. But as far as the image and distribution go, it could make a big difference, or even like give the testability a long sought after question, even if it's not about layer optimizations of running and fetching and whatnot. Is just saying, actually, I just need to know if like bin bash or bin php has a certain checksum, because I'm looking for that particular file and they have to download and extract 500 megs worth of tar to find out is the particular binary that they're looking for the exact version, the exact hash that they're looking for. So there's kind of like this introspection SBOM piece of it it comes from both angles, but it's very important.
Do people think that this file system representation would be valuable independent from an actual runtime capability? So just having this as part of or having the manifest point to this, just for being able to do things like verification?
The verification opens a whole can of worms. Like this is one of the things we've been trying to figure out. Like if we are, like when we expand things in ACR for the teleport stuff, well, what does that mean? Because you actually sign the digest of the tar, not the original. So we've been talking about, do you sign the original content first and all of that. So I don't know what it means to use it for verification to have it expanded. Like I guess the main value of what you're thinking is like, can we get the perf thing better? Because there's so many different experiments and attempts at this, and I haven't seen anybody really land a general approach. Like what our goal with the ACR stuff was, you should not care. You push an image built like a normal way, we'll expand it, quick mount it, don't worry about it. You don't have to do anything different. Yeah, you should make your images smaller always, but like you shouldn't have to build it special to do this. We're just facing a lot of challenges with it, and I'm curious how far you've gotten. And there's probably other values out of this, but the perf seems to be the biggest hit, the biggest value.
I'd say perf is the biggest value at runtime, and then cost of storage. So like in cost of build. So if someone's building on their laptop, rather than them having to upload a 400 megabyte layer, being able to upload the 40 meg jar that they edited.
Oh, in other words, it's almost your dedupe taken to the next level.
Right.
Yeah.
He's like a lot of.
Yeah, because then you have only the 40 meg jar pushed, only the 40 meg jar pulled, potentially only the 40 meg jar, changed on the registry side. So you start hitting like several different orders of where that storage and bandwidth is consumed.
So I didn't see who said it, but someone commented about multi-arc in the chat. This is actually also a reason why we're like worried. If we've suddenly said that we're taking the entire registry and doubling it in size, that's gonna be a number that will register in terms of cost, and in terms of build
Especially
time.
if you don't delete anything.
Yeah, we might have to start doing that. And like ARM is starting to become a real threat, right? Like that people want to use to x86, and like a lot of laptops seem to be going in that direction. So it's something that the current layer format doesn't handle super well either.
do you see it like the way we've been treating it as an optimization after the fact? So if it hasn't been accessed in a while, delete, that format and keep it in its original tar. That's what the Nidus folks were doing with the reference types. What they liked about it was you keep the original, you store it as that, and so that it is not all your content doesn't keep as expanded in individual files, just the active content, whatever that means.
Yeah, I mean, I think that there's a ton of solutions that are doing clever things, but the place that we've kind of hit the wall is that until it's in the specification and in OCI in general, it's really hard to actually have effectiveness of these mechanisms at scale.
So I just push back on it just in the sense of it's hard to put it in the spec and standardize until we know if it actually works. Like there's a bunch of things in this that I would have loved to push in and have end-to-end tools, but everything I'm not saying for your case exactly, but for the very similar case, the things we initially thought did not work out as well as we had hoped for, SMB mounts, for instance. So if you can get a tool chain that only works in your environment, just because you actually own the registry right down to the deployment, and you can even if you can mimic the environment, like if you can say, hey, especially because you're running on distribution, hey, here's a version of distribution that has this in it. Here's a client that's hacked up to know how to reconstruct it on a node, throw your image at it, and then we could all hack on it. And then if we could figure out, wow, this really does work, and these edge cases are things we could fix, then you can start to, I don't know, it becomes so compelling that the tools will definitely jump on it, whether or not it's in the spec.
So we're just using, like with our POC on this, we're just using the registry out of the box. We did not alter registry at all. And that was one of the requirements of the POC, because again, we want to be able to one day use someone else's registry. And building a snapshot or a containerd snapshotter is definitely a doable thing. The problem that we've had is, what about the dev side of this? Until the development tool chain will be able to do this and we can get it onto people's laptops or onto build boxes, it's really hard to get the end-to-end experience. And OCI doesn't lend itself to altering the image after the fact unless you have some kind of external metadata.
We could talk about the reference type thing, but it's right. If the way we've been treating it, because we actually built the teleport thing without the reference types. What happens is the client knows the digest of the original manifest, and we just have a mapping on the server that says, hey, that original manifest goes over here, and you can go off and do all of the interesting things. So I guess my point is you can do this without changing the dev tooling. It pushes up when it gets received at the registry, the expansion happens, and then the client knows how to pull it. And I'm not saying we shouldn't absolutely solve the dev tooling thing. We were chewing at a couple of those as well, and we realized we really need to, we solved the expansion, and we have a teleport D, shim that we do. It's that part we haven't solved. So it doesn't matter how we solve the other parts yet, because we haven't solved that performance all the way that we wanted to yet. So I guess maybe that's what I'm encouraging is can we land proving that real performance part works, and then if it does, then we can just shim in the dev tooling.
Yeah, I mean,
if we needed it.
We can probably release our snapshotter externally, or release it as a snapshotter, and the kernel patches that are required for this.
I think Matt's been trying to talk here.
I'm mostly curious what the validation you want to see for this is, Steve. I mean, it sounds like you're not seeing the validation you want to see from teleportation, but you'd like to, and I'm wondering what that validation is. Is it just performance?
Good question. So it certainly the key value was performance. And in fact, we've solved, and that's a good question. We've solved some of the performance thing. We proved performance is much, much faster. The problem that we found, to be completely transparent, is by using SMB and using premium files, all the infrastructure we built around VNetting blobs, CMKing blobs, all of that long list of features I always talk about why you shouldn't build yet another storage service, turned out we had to reboot a lot of that on top of the SMB mounts. And that even though we had most of the performance problems solved, there was a long list of, oh great, now we have to duplicate all of this on that infrastructure as well. And in addition to the fact that premium files are premium and expensive. And so I'm not trying to block anything. I'm just saying like what we found is you kind of have to go a little further with it and say, throw a whole bunch of different images, ML images, which apparently have duplicate layers of the exact same layer in the manifest, and that caused us to blow up. Layers that are more than 67 layers, and that blew up something in our stack. There's just a bunch of those edge cases. What's that? What was that, Vincent?
Device mapper. We had a hard limit of how many layers, and it was device mapper. I think AUFS do device.
Yeah, I think he's mentioning the layer limit being a problem.
Yeah. So I'm just saying that some of those we were just hitting in other cases. So if you can had that's what I'm curious. I'm not even asking you to prove it to me. How much have you had confidence in throwing lots of different layers and saying, wow, if I just have tooling, I'd be done? Or is the performance work really validated for yourself, much less anybody else?
Yeah, I mean, I think that it's much harder for us to publicly validate the performance information and prove that, because like that's built on our own infrastructure. But in terms of like, does this work and is it stable? That's pretty easy for us to release. And like, we've processed our top 100 most popular images through this, and we have a lot of statistics around how much storage saving there is and how much network we save. And those are things we could probably publish, or at least we could publish the tools for people to run the same kind of thing on their images to see if they would see the same kind of performance improvements. So I guess it seems like people are interested enough for us to continue to pursue this and release our tooling, and I guess we'll go from there.
Super cool.
I was curious, have you tried to do or work with the StarGZ team? Have you tried to do any pull requests, try to merge your efforts?
No, but like our needs are somewhat independent of what they're doing, because we still want this metadata independent of the format for being able to power things like offline deduplication. And we could do that with StarGZ just fine. We can like take the TOC in StarGZ and scan that. StarGZ kind of runs into the same problem though, of like, it's not the thing that's in OCI. It's like getting images all to StarGZ is not really that trivial. But I think in the doc, I actually state that like it fulfills almost all of the
Yeah,
requirements.
that's why I was asking. You know, and then they're working on the tooling too. It just seemed an opportunity for you guys to converge efforts if possible. If not, that's
at least one of them dialed in.
What was that?
I said I think I see at least one of them dialed in. I don't know if they're there or not.
You talking about Samuel or?
No, Kohei?
Oh, hi. Yeah, I'm Kohei from E30 and Study Snapshot. And maybe I missed the question, but it was, I guess it was about tooling around images. And yeah, I think tooling can be one of the major problems when it comes to new image format. And because there are lots of tools that need to parse the image, like builders and runtimes and registries. And but yeah, I think it's not impossible. Nowadays, BuildKit can, the master version of BuildKit can build ESRGs, and the tools around Go Container Registry also understands ESRG format. So yeah, I think it is not easy, but I think it is not impossible to modify tools to make it possible as a new image format, I think.
So I think right now with Conoco, Co, build packs, if you set an environment variable, every single one of them will start emitting eStarGZ layers for their contribution to things. So,
does anyone have background of why StarGZ hasn't become the format?
I think we just used the archived tar from Golang and made everything else work around it for a long time. I'm pretty sure if Docker had adopted StarGZ, then it would have happened. In my recollection, Giuseppe from the Red Hat team was investigating it around the same time that the Golang team, when Brad Fitz did the container, the registry file system, used StarGZ, and they, like a lot of people started looking at it a lot more specifically for this, but it was just going on momentum of what had been happened before. I think if we started putting it in the MIME type and just had it become ubiquitous, I'm pretty sure, like you just named off a few, the Red Hat containers image repo that Cryo and Podman and all those tools use, I think all already support StarGZ.
And do you know why the I guess, is it just that no one has yet suggested that OCI layers start using StarGZ by default? Or I guess what's the reason why the layer format has stayed the way it is?
I mean, I think it's, I mean, my personal opinion, I think there's somewhat of a chicken and egg problem. The StarGZ snapshotter was something you had to install separately. And so there was some cost to enabling it because I think the images are slightly larger, et cetera. But it wasn't available in the standard snapshotter. So that's come up in at least some contexts that I've seen it in. But yeah, I mean, yeah. I'm going to ramble, so I'm going to shut up.
Yeah, no, I mean, I think John has his hand up, but I'll just, I mean, to that point, it's like NerdCTL now packages, like if you download their release, you get OCI encryption, you get StarGZ snapshotter, like, but that's only been for a few months. And I think if those tools aren't at your hand, like, you're just going to use Docker push, like yeah. So I think there is that chicken and egg, like, somebody has to start using it, and then it's like there's there's kind of that. Anyway, John, I'll let you say something.
Yeah, I think that's the large problem is just momentum. I mean, you need to get the remote snapshotter into Containerd distributions on all the cloud providers for their Kubernetes installs, or make it possible to configure that. I think the reason there's so much inertia is that, like, worse is better is winning here, right? Like, I can understand all of the image format with JQ and tar and gzip. There's not, I mean, I wrote one. There are tools to StarGZify stuff, but it's complicated. It's a lot more complicated than like tar. So it's hard to get traction on that, I think.
Well, but I mean, part of the reason that we tried to sort of make it so that you can just set an environment variable on all the GGCR based tools would sort of get this for free was so that if we wanted to flip the switch and start putting images out there that, you know, solve the other side of the chicken and egg problem, which is like motivating, getting you know, folks to include the StarGZ snapshotter at runtime, because all of these images could start to take advantage of it, right? Like that's another piece of it. But yeah.
So just to jump in and say, we're like in our, what was like a 30-minute open discussion time, which I think this has been great. This is not an attempt to stop.
This was open discussion. It was great.
Yeah, this is open discussion. So we're cool. The only reason I'm saying it is like, if there's something someone waited all day, like, I'll use that last 30 minutes. Like now's your chance. And if not, we can probably wrap a little early too. I know some people have hard stops, so.
There were a few things sitting in the parking lot part of the doc. Not sure if any of that we want to pull on any of those threads now, or not anywhere near enough time to start digging into some of these new issues. Selfishly,
don't each of those need like an hour or two?
Probably. I'm thinking selfishly, I could pick on like the name spacing tags. One of the things I had thought about was what it would look like to revamp the whole tag list API. And thoughts in that is, it would be nice if we return, instead of just the string for the tag, return an entire descriptor so you can see the digest and other things in there. And then doing that switch, you'd need to have some kind of accepts header so you'd know that you need to return the new tag list versus the backward compatible tag list. But the reason the conversation came up today was thinking about namespacing the tag listings. And so you could potentially say, have a tag list, but only give me the tags for this media type. And then potentially have multiple things in there with possibly conflicting tags, tag names, tag values. But since they have different media types, they wouldn't be impacting each other. So dropping that little thought process out there, and I'm sure people are saying, oh no, that sounds horrible, but.
Sorry. We can do that. Oh no, that sounds horrible in a future dev call. You can, I'll even permit being able to put that as like a direct subtitle for that particular discussion.
Are there big things in that sound complete showstoppers that it's not even worth raising an issue or PR or something like that on distribution? Or is that something that's worth trying to flesh out and put down in writing?
I'm curious if you're familiar with some of the stuff GCR's been doing for many years now, sort of extending the tags list endpoint, because it does some of the things you just described.
I am not, so I'll be curious what they've already done and how that might be able to be leveraged.
Curl the endpoint. We return stuff like subdirectories, digests, a bunch of things that I think are useful to that.
Media types.
UI and stuff like that, yeah.
So you just extend the return JSON.
Yeah, it's just JSON fields that are outside of the schema.
Got it.
So
there was a issue or PR, I can't remember which, that I started a while ago. I was just trying to capture what are all these kind of needs. So we didn't keep on revisiting the same API going, oh, wait, there's one more. And oh, if we structured it this way. Because I think there are a ton of things, whether you're filtering by, and by media type, I'm not sure if that's kind of like saying, is it an image versus a Helm chart, or if it's an index versus a manifest. But the point is that I think there are a bunch of interesting things. Whether it's the tag, maybe the date it was pushed, for instance, back to some of that ordering thing. So personally, I'd just love to see us capture all the things we'd want to try to get from some of these listing APIs so that we could design an updated version of it that encaptured all those things.
So I think just for a little more context on why we did it in GCR, I think the motivation was to basically present all the information we needed for the UI, which included being able to enumerate untagged digests and directories and things like that. I don't think we did anything around filtering or anything like that, but yeah, I mean,
we have a similar context on ACR as well. There's an entirely different API that gives you the actual push digest, because depending on the client, you get different digests, which you cannot trust. So every cloud ends up inventing this part.
Yeah, so if everybody is reinventing it, does it make sense to start pulling something together that every cloud can work together on?
Yeah, I think so. I mean, there's some useful things that we played around with in the CLI tool built around the GGCR library to do things like recursively copying images and stuff like that. You just can't do without some of this information. So at least in a portable way. So it would be nice to be able to do those things in a portable way.
Are you talking about Crane?
Yeah. Well, there's a G Crane variant which exposes some additional stuff, but yeah.
So that was all I was going to drop on the meeting. People want to get out of here 10 minutes early, I won't hold you hostage.
So next year, we'll do it in person. If there's no outstanding pandemic.
You just jinxed it, Josh. Thanks.
I mean, we'll see what happens. But we'll do it in North Carolina.
I'm not sure how Vincent's going to manage to get in the walk to the park and the washing the baby and everything else all at the same time.
There'll still be a remote option.
I say we do it at Vincent's house.
That'd be wonderful.
No, this is good. This worked better than I thought it was going to, as far as being able to make sure that like everybody could hear each other and everybody in the room can hear each other as well. So yeah.
Yeah, it's really good on this side. And John and Brandon, your cameras are very professional. You're on like a 15-foot wide screen and I can see everything.
Yeah, actually, Mike Purcell also had like a 4K something. Like he was like pixel perfect. I don't know what he was using. And then there's VBATs on his cell phone. But anyway.
Yeah, I was gonna say, I was literally putting little one to bed, singing songs while you're talking. Jeez. All right. I'll have y'all here. Come on over to the house.
That was great.
Bill, because you kicked us off, like, go ahead and close us out.
All right. So it's yeah, good discussions. A lot of information, and we've got our Wednesday call. We can go back to harassing each other on every week.
Point of order.
Oh, Thursday
at 10 a.m. Correct.
Yeah.
The call formerly known as Wednesdays.
Yeah, don't ever show up on Wednesday ever again. Thursday.
Do we have an action item to do an international version?
It is an international version. It's earlier in the day.
I hope y'all that are in person get to like share tea or coffee together.
We did.
Just at lunchtime.
We actually had Seattle dogs for the afternoon snack. I don't know what they were, but they had a paper that called them Seattle dogs.
We also got caught in the Seattle rain together, so that was.
Go grab a Seattle drink afterwards and enjoy yourself.
Cool. Well, thanks everybody, and thanks Amy and LF people for making this work. Yeah, I think the setup was even better than I expected. So.
Thank you, Amy.
It worked. It worked. All right, everybody out. It's good to see all of you.
Yep.
Bye. Thanks, Amy.
Bye, everybody.
Bye, all.
Not from you guys, I think.
We're done. We don't want to see each other for a while.
Hey, I heard that.
That's funny, it's still there. My laptop's closed, you think you're done, like, Mike's like, nope, still here.
Go home.
What was that movie where like they go into the credits and you're watching the whole end of the credits? And so why are you still
Matthew Broderick.
What was that?
Ferris Bueller's Day Off.
Right, it was Ferris Bueller, yes.
See you guys.
Take care, Mike. Thanks for taking so late.
Hi, this is Susie calling with the Vehicle Service Department. We are calling about your vehicle's manufacturer's warranty. We sent you several notices in the mail that you have yet to extend your warranty past the factory cutoff.
I think the recording's still going, so you might want to go hit end meeting on the computer.
All right, Cannon, how do we do this? I don't, even though I'm dialed in, I think I'm just.
You should be able to take over as the host. There should be a button for that somewhere.
Do I show up as open containers?
You do, as a co-host.
Oh, look at that. Even on the phone, I have claim host.
There you go. Now you're the host and you can hit end meeting. Bye.
End this all. Thanks, T.